Hello and welcome to the lecture of transient analysis. In this lecture we will talk about the initial conditions. So this analysis is free from your first order limitation. We can go up to second order also. Means you can see capacitor, inductor, means this both the components can be connected in the one circuit. तो ये जो एनालिसिस है, इस एनालिसिस में हमने एक जो एनर्जी स्टोरिंग एलिमेंट था, एक टाइप का जो एनर्जी स्टोरिंग एलिमेंट था, उस रेस्ट्रिक्शन से हमने इसको फ्री कर दिया है. हम यहाँ पे एक से ज्यादा भी एनर्जी स्टोरिंग एलिमेंट रख सकते हैं. करेक्ट. तो द जनरल आइडिया ये है, द बेसिक फंडामेंटल आइडिया ऑफ कैलकुलेटिंग इनिशियल कंडीशंस, दैट इनिशियल कंडीशन इज ऑलवेज इक्विवेलेंट टू द ऑर्डर ऑफ डिफरेंशियल इक्वेशन. है ना. कितने इनिशियल कंडीशंस की रिक्वायरमेंट होती है? नंबर ऑफ इनिशियल कंडीशंस, number of initial conditions is equivalent to order of differential equation. So in this analysis, we are not interested in the complete solution. We are interested in how many initial condition we can find, and we can find as many as initial condition we want. So we will see this type of analysis in this circuits in this session. So maybe we will talk about the initial condition of current, then derivative of initial condition of the current. If the solution of differential equation is solution of differential equation is available, अगर किसी डिफरेंशियल इक्वेशन का सॉल्यूशन अवेलेबल है तो वो तो सारे पॉइंट पे कंटिन्यूअस है, और कंटिन्यूअस है तो उसके सारे डेरिवेटिव की भी इनिशियल कंडीशंस निकाली जा सकती है. मींस वी कैन फाइंड द इनिशियल कंडीशंस ऑफ ऑल द डेरिवेटिव्स आल्सो. सो हाउ टू परफॉर्म दिस एनालिसिस, एंड फॉर दिस एनालिसिस वी आर हैविंग वन बेसिक सर्किट. सो व्हाट क्वेश्चन इज सेइंग? The question is saying that in the network figure, K switch is closed at t equal to 0. So initially switch is open. Can I say at t0 minus switch is open and switch is closed for t greater than 0. If switch is switch is open at t less than 0 means no energy is stored across the capacitor. Means ये कैपेसिटर में कोई एनर्जी स्टोर्ड होगी ही नहीं. और अगर कैपेसिटर में कोई स्टोर्ड एनर्जी होगी ही नहीं, सो व्हाट इज इनिशियल कंडीशन ऑफ द वोल्टेज अक्रॉस कैपेसिटर? तो कैपेसिटर के अक्रॉस so voltage across capacitor will be what? The voltage across capacitor will be 0. So let's talk about this. So we don't have to analyze this circuit for t less than 0. Can I say the circuit at t0 plus? Because we are interested in I di by dt and d2i by dt. जो करंट है उसके हम फर्स्ट डेरिवेटिव की बात कर रहे हैं, करंट की बात कर रहे हैं, एंड वी आर टॉकिंग अबाउट द सेकेंड डेरिवेटिव ऑफ द करंट ऑल्सो, बट ऑल दिस वैल्यूज वी वांट एट t इक्वल टू 0 प्लस. सो लेट्स ड्रॉ दिस सर्किट एट t0 प्लस. just after the switching. Just after the switching, what is the condition? The condition is capacitor is having 0 voltage, means you can replace your capacitor by short circuit. So only two things are available in the network. One is voltage source you are applying and second is resistance. So can I say my circuit at t equal to 0 plus will looks like this? If I analyze the circuit at t equal to 0 plus, because circuit at t equal to 0 plus will gives you the current at 0 plus. So what is the situation? The circuit at t equal to 0 plus is given by, we are having this, then we are having one voltage source. And what is value of the voltage source? The value of voltage source is 100 volt. We are having 100 volt. Source. Then what we are having? We are having here a resistance, and at t equal to 0 plus the switch is closed. And what is the value of resistance? The value of resistance in the circuit is given as 1000 ohm. So this resistance is 1000 ohm. And what is the initial volt? Because you are having one energy storing element, so at t0 minus the switch was open, so no current across the capacitor. If no current across the capacitor, the voltage across the capacitor is also equivalent to 0. So I will replace my capacitor by short circuit. I will apply a short here. I have replaced the capacitor by short circuit. And at this moment, what current you can expect? At this moment, you can expect current I0 plus. And what is value of I0 plus? The value of I0 plus can be given by applied voltage divided by resistance. So what is applied voltage? Applied voltage is 100 volt and divided by resistance is 1000. So current we can expect from the circuit is 0.1. 0.1 ampere is the initial current in the circuit. But remember, this circuit is only valid for T. This circuit is valid for T. This circuit is valid for T equal to 0 plus. Correct? Now, can I say, now we are interested in di by dt. We are interested in di by dt at 0 plus. We don't want a general solution of di by dt. We want a di by dt for t0 plus. There are two ways to approach this type of questions. First is, what is first approach? First approach, find the complete value of it, then calculate di by dt, then calculate the second derivative. But we can do before that, means we don't have to go that long. We can solve this question directly. Can I say the circuit for t greater than 0 looks like this? For t greater than 0, the circuit looks like this. Greater than or equal to 0, circuit looks like this. We are having a voltage source. This voltage source is having value 100. एक voltage source है जिसका value है 100. एक resistance लगा है 1 किलो ओम का. And और क्या दिया है? एक कैपेसिटर दिया है, so I can write the capacitor C. What is the value of capacitor? The value of capacitor is 1 microfarad. ये value आपको कैपेसिटर के लिए, कैपेसिटर का जो वैल्यू है वो 1 माइक्रोफेरेड है. अगर इस इक्वेशन के लिए मुझे KVL लिखना पड़े, if I am interested in writing KVL across this, how KVL will looks like? So this value will be what? 100 volt. What I am doing? I am applying KVL in this mesh. 100 volt. This is, what is potential drop? IT is the current. And 0, 100, so 1000. So 1000 times of IT minus this value will be what? C dV by dt. So C, 1 by C integration of I dt. So 1 by C, C is 1 microfarad and integration of IT dt। यहां पे करंट का वैल्यू हम लिख सकते हैं, वोल्टेज का वैल्यू लिख सकते हैं। What is the value of current? What is the value of voltage? The value of voltage is 1 by C integration of integration of I dt, and summation of this voltage is equivalent to 0. ये एक डिफरेंशियल इक्वेशन में कन्वर्ट किया जा सकता है। ये इंटीग्रेशन एक ऑपरेटर अवेलेबल है, तो हम एक काम करें, इस इक्वेशन को, इक्वेशन नंबर 1 कैन बी डिफरेंशिएटेड बोथ साइड। सो व्हाट इज डिफरेंशिएशन ऑफ 100? इट इज 0 माइनस 1000 times of dit divided by dt, and this value is what? Minus it divided by c equal to 0. Now what you can say, this equation is valid for t greater than or equal to 0, because this is one differential equation, और जितनी भी differential equation है वो t greater than और 0 पे valid है। और अगर ये differential equation t greater than 0 पे valid है, तो हम यहां लिख सकते हैं 1000 times of di0 plus divided by dt, क्योंकि डिफरेंशियल इक्वेशन का जो सॉल्यूशन है वो भी t ग्रेटर देन और इक्वल टू 0 पे वैलिड है, माइनस ऑफ it डिवाइडेड बाय c। तो इसको मैं लिख देता हूं माइनस ऑफ I0 प्लस डिवाइडेड बाय c। नाउ आई एम इंटरेस्टेड इन द वैल्यू ऑफ di0 प्लस डिवाइडेड बाय dt। हमें किस वैल्यू में इंटरेस्ट है कि di बाय dt का वैल्यू एट t इक्वल टू 0 प्लस। तो t इक्वल टू 0 प्लस पे ये इक्वेशन परफेक्ट है और ये इक्वेशन परफेक्ट है, तो di बाई dt का वैल्यू लिख सकते हैं हम माइनस 1 बाई 1000 इंटू सी इंटू I0 प्लस, और आई कैन से di0 प्लस डिवाइडेड बाई dt, इस एक्सप्रेशन का जो वैल्यू होगा वो दैट वैल्यू इज माइनस ऑफ I0 प्लस डिवाइडेड बाय 1000 into C. And what is the value of the capacitor? The value of capacitor is given as 1 microfarad. So this value is 10 raised to the power 1 microfarad. 1 microfarad can be written as 10 raised to the power minus of 6. So 3 power cancel and this value will be what? 10 raised to the power 3 ampere per second. Always remember how current is varying with time. The current is varying with time is minus 10 raised to the power 3 ampere per second. So VR R equal to 1000, C equal to what? Okay, I0 plus is also known to us. Let me write. This value is minus of I0 plus divided by 1000 into 10 raised to the power minus of 6. What is value of I0 plus? Can I say the value of I0 plus is 0.1 ampere? So this is 0.1 divided by 10 raised to the power minus 3. And when it goes in numerator, this will be what? Minus of 100. And what is unit of this? This is rate of change of current with respect to time. So this is 100 ampere per second. So you can say that the value of di0 plus divided by dt is minus 100 ampere per second. So when you are writing the solution of differential equation, you can use anything. You can use this as initial condition. You can use previous thing as initial condition for constant calculation of differential equation. This is the value of di0 plus divided by dt. What next we can have? The next we can have, we are interested in one more thing. And what is one more thing? We are interested in the second derivative also, and we can go up to any derivative. So how to calculate the second derivative? To calculate the second derivative, just integrate, just differentiate this. So I have my equation as minus 1000 times of, this is the calculation of d2it divided by dt2 at t equal to 0 plus. We want to calculate this. तो इसको कैसे कैलकुलेट किया जाए कि हमारे पास जो इक्वेशन अवेलेबल है माइनस डी बाई डी टी का इक्वेशन जो अवेलेबल है वो कितना है, डी आई टी डिवाइडेड बाई डी टी. इस इक्वेशन का जो वैल्यू है दैट वैल्यू इज इक्वलेंट टू माइनस ऑफ आई टी डिवाइडेड बाय 1000 इंटू 10⁻⁻⁻6. इतना वैल्यू अवेलेबल है. या मैं ऐसा लिख सकता हूं कि डी आई टी डिवाइडेड बाई डी टी, द वैल्यू ऑफ दिस इज माइनस ऑफ 1000 इंटू आई टी. If I am interested in the second derivative, let's take the one more derivative of this equation. So let's take d by dt both side. D by dt both side. If I take derivative both side, what is derivative of this function? The derivative of this function will be d2i divided by d2t. And this value will be minus 1000 times of di by dt. Now what I can say, we know the value, but we don't want a general solution of this equation. Even either we can find the general solution, that is not difficult task, but we are not interested in the general solution of this equation. We are interested in the solution of we are interested in this parameter. So can I say d2it at 0 plus is equivalent to minus of 1000 times of derivative of current with respect to time at t0 plus, and that value is minus 100. This value will be what? Minus of 100. So 100 cancel and 3 into 2. What is value of this? 10 raised to the power 5. And what will be the unit? Unit will be ampere per second square. So you can go up to any number of initial conditions. So this is first initial condition for the variable, second initial condition is available for the first derivative, and third initial condition is available for second derivative. This is how we can calculate the initial condition, and this is very popular category of question they asked in GATE exam. First, second and third. I hope this analysis is clear. Although we can find the final answer for this capacitor's voltage also, we can write the equation. A KVL and KVL will give us the complete solution for IT. But we are not interested in complete solution. We are interested in interested in what? We are just interested in these values, initial values, initial condition. Okay. One more question from the book. The previous question was based on RC circuit. The previous circuit was RC circuit. Now we are having question with inductor. Can I say in this circuit what they are talking about? Again they are asking about same thing, I di by dt and d2i divided by dt2. Now what is the switch position? We can say that the switch position is this: at t less than 0, switch was open, and for t greater than 0 the switch was closed. Now one thing we can very easily calculate this time. If switch is open at t less than 0, and what is energy storing element in the circuit? The energy storing element in the circuit is current. So can I say I0 minus the current across inductor for t less than 0 is 0. So I0 plus is also equivalent to 0. One thing you can directly calculate, because the current across inductor do not change abruptly, correct? Second condition, what is the second condition? We are interested in the di by dt also. So let's draw the circuit for t greater than 0. If I draw the circuit at t greater than 0, how circuit will looks like? Here we are having a battery of 100 volt. Here we are having a battery of 100 volt. Then we are having what? A resistance of how many ohms? The resistance of 10 ohm. And then we are having one inductor. And what is value of inductor? The value of inductor is 1 Henry. If I write a KVL equation around it, what this value is? This is 100 volt minus 10 times of IT. And what is voltage across inductor? The voltage across inductor is very simple thing. It is minus of L di by dt. So this is 100 minus 10 times of IT and plus and this value will be what? Always remember the current will enter from this polarity. So what is potential drop? Potential drop is dit divided by dt. The current multiplied by L di by dt. So this is the value. Now we know that the solution of this differential equation or this differential equation is valid for t greater than or equal to 0. Solution is valid for t greater than or equal to 0. So can I say 100 is equivalent to 10 times of IT plus dit divided by dt. This is our equation. And this equation is also true for t equal to 0 per. Equation is, or you can say equation is valid for t greater than or equal to 0. The solution of this equation valid for t greater than or equal to 0. So can I say at t equal to 0 plus how our equation will behave? 100 is equivalent to 10 times of I0 plus di0 plus divided by t. Correct? Now we can say I0 plus value is equivalent to 0. We have already calculated it. I0 plus का जो value होगा वो कितना होगा? 0 होगा. And if this value is 0, the rate of change of current in the inductor is given by 100 ampere per second. This is our first answer. What is this value? This value is 100 ampere per second. 100 ampere per second is one of the answer we are having from the circuit. What is the second answer? For getting the second answer, to calculate the second derivative, what is the procedure? Procedure is same. You have to calculate d2i divided by dt2 at t equal to 0 plus. हमें second derivative की requirement है at t equal to 0 plus. And how we can write it? Just differentiate this equation. So if I differentiate this equation, what is our equation? 100 is equivalent to 10 times of IT. Hundred is equivalent to 10 times of IT plus we are having dit divided by dt. If we are taking derivative both sides, what is derivative of 100? The derivative of 100 is 0. So this is 0 plus 10 dit divided by dt plus d2it divided by dt2 equal to 0. It is given. If this value is equivalent to 0, can I say my answer for the circuit is what? 10 times of minus 10 times of di0 plus divided by dt is equivalent to d2i plus divided by dt2. I am interested in this value, and di0 plus divided by dt is already known. What is this value? 100 ampere per second. So can I say minus 10 into 100 ampere per second. So what is the value of second derivative? The value of second derivative is given by minus of 1000 ampere per second square. This is how we can calculate the initial condition, and we can calculate n number of initial condition. There is no problem in calculation. This value is what? This value is minus 100 ampere per centimeter square. Chakravarti circuit analysis. Chakravarti circuit analysis. Yes, you can solve, Sunita, you can solve Chakravarti circuit analysis, but what is the problem with this book? A very large, very huge number of problems are given. So be specific and try to solve first, try to solve PYQ by the concept. That will be a better approach. Circuit analysis, Chakravarti book is very big in size. If you are solving it and maximum solution, there are mistakes in that book also. So be careful. Anyways, this is our two questions, and these questions are based on what? These questions are based on initial condition. Let's take few more examples, and one more example is this. What this example is saying, these are the question from a standard book, and what this question is saying, this question is saying that the network shown in the figure has steady state when switch K is closed. Okay, the steady state is achieved when switch K is closed. The switch is opened at t equal to 0. Determine the voltage across the switch. Okay, a circuit is given like this. I hope circuit is clearly visible, or let me draw the circuit. We are having this kind of circuit. एक सर्किट है हमारे पास जिसमें कुछ दिया है आपको एक वोल्टेज सोर्स. दिस इज वन, एक 2 वोल्ट का वोल्टेज सोर्स दिया है आपको, और क्या दिया है? और दिया है एक कैपेसिटर के ऊपर स्विच लगाया हुआ है. दिस इज कैपेसिटर, और कैपेसिटर की जो कैपेसिटी है वो है 1/2 फैरेड. करेक्ट. एंड वन स्विच इज गिवन. सर्किट फिर कंटिन्यूअस है. एक दिया है आपको इंडक्टर, एंड देन 1 ओम रेजिस्टेंस. वन ओम रेजिस्टेंस गिवन है, और दिया है आपको 1 हेनरी इंडक्टर, एंड हियर दे हैव कनेक्टेड वन स्विच. स्विच का पोजीशन क्या है? स्विच के अक्रॉस जो वोल्टेज है उस वोल्टेज को बोला है कि दिस वोल्टेज इज VK. दिस वोल्टेज इज VK, द वोल्टेज अक्रॉस स्विच. दिस इज योर ओरिजिनल क्वेश्चन. एंड व्हाट इज द पोजीशन ऑफ द स्विच? व्हेन यू लुक एट द स्विच, इनिशियली स्विच वाज क्लोज. Initially switch was closed. If switch was closed, what is the VK? Can I say VK0 minus, if switch was closed, what is VK0 minus? The VK0 minus is what? VK0 minus is 0. Yes or no? If switch is closed, how, what we can say? For t less than 0, switch was closed and for t greater than 0, the switch was open. Correct? For t less than 0, switch is closed. For t greater than 0, switch is open. If I draw the circuit at t less than 0 or t0 minus, because every as I have told you that every condition of the switch is what? Stable, steady state condition, stable condition. So switch is available at from t equal to minus infinite to t equal to 0 minus in this duration. The switch was closed. So if switch was closed, let's draw all the components in steady state. So when I go to the next page, can I say, when I go to the next page, what I can say, we are drawing the circuit at t0 minus, and always remember this point is which point? This point is a steady state point. This is the steady state point of closed switch. So first we are having 2 volt. This is 2 volt. What is the position of the switch? The switch is closed. If the switch is closed, there is no meaning of capacitor. But as we know that in steady state, capacitor also act as a open circuit. What next we are having? Next we are having one inductor, and how inductor will behave? The inductor will behave as a short circuit. And how capacitor will behave? In a steady state, open circuit. Correct? What else is given? 1 ohm resistance is given. So here we are having 1 ohm resistance. This is 1 ohm resistance. This is our overall circuit. In this circuit we are having only one component. Remaining 2 components are behaving they are showing their steady state characteristics. So can I say the current will not enter into this? If current will not enter into this, what is current in this? 2 divided by 1. And this is the value of I0 what? I0 minus. And 2 divided by 1 is the current across the inductor also. So can I say I0 minus equal to I0 plus, because inductor will hold this current. The current across inductor will not change abruptly. Now how your circuit is behaving for t greater than 0, can I say for t greater than 0, for t greater than or equal to 0, now switch is open. If switch is open, can I say here we are having 2 volt. Now if switch is open, this is the path for current now, because switch is open, so current will not flow through the open circuit. The switch is open now. Open. Then we are having what? Then we are having one inductor, and now inductor is converted into what? Now inductor is converted into the current source. And what is the direction of current source? So this is the direction of current source inductor is holding. So this is also direction of current source, and that value is equivalent to what? That value is equivalent to 2 एम्पियर. तो यहाँ से फ्लो होने वाले करंट का जो वैल्यू है वो है 2 एम्पियर. अगर ये 2 एम्पियर करंट का वैल्यू है, then what is resistance we are having? The resistance we are having is 1 ohm. Now can I say, and what voltage is Vk? This voltage is Vk. Okay. So can I say at t not greater than or equal to 0 plus, I am saying that my circuit will looks like this at t equal to 0 plus. Now we are interested in current across this. Can you tell me what is current across capacitor? The current across capacitor at t0 plus is what? Current across capacitor is what? C dVk divided by dt. C dVk by dt is the current across capacitor, but we know that the current across capacitor is already given at 0 plus. What is that current? That current is equivalent to 2 ampere. Why it is 2 ampere? Because inductor will copy this current from T0 minus to T0 plus, and we are drawing our circuit at T0 plus only. So C dVk divided by dt equal to what? This is 2 ampere current. And always remember polarity, current will enter from the positive polarity. So this is fine. If this is fine, dVk divided by dt is equivalent to what? 2 divided by C. And what is the value of C? The value of capacitor is half farad. So this value is half farad. This is half farad. So what is dVk divided by dt at t equal to 0 plus? This value is 4 volt per second. Always remember, it is not necessary that if some voltage is 0, then rate of change of that voltage is also equivalent to 0. No, we are talking about rate of change of voltage, and rate of change of voltage can vary. So what is the answer? 4 volt per second is the correct answer for this given question. I hope this is clear. Let's go to the next part. Let's go to the next question. Let's try one more question based on the concept. Okay, this is our question. What this question is saying? This question is saying that there is one switch P and P is connected to, let me draw the circuit clearly. First, let me draw the circuit. How circuit will looks like? A 20 volt source. We are having 120 volt source. Then we are having 120 kilo ohm resistance. This 20 kilo resistance. What else we are having? 5 kilo resistance. One 5 kilo ohm resistance. What else we are having? Then we are having one switch. Then we are having one switch. And this is the remaining part of the network. What is remaining part of the network? Remaining part of the network consists of one 5 kilo ohm resistance. Then we are having one capacitor. And what is the value of capacitor? The value of capacitor is 1 millifarad. And they are calling this voltage as Vt. What else is given? A 10 kilo ohm resistance is given. 10 kilo ohm resistance. And one inductor is given as 0.1 millihenry. One inductor is also given. What is the switch position? The switch position is this. It is moving from point P to point Q. 2 points are mentioned, and it is going from point P to point Q at t equal to 0. Then they are asking about dV divided by dt at t0 plus. Means what is the rate of change of this voltage at t0 plus. Let's analyze the circuit for t0 minus. Can I say at t0 minus, let me draw the circuit switch correctly. The switch is having this position. So switch is initially connected to the P point and now it is connected to the Q point. So can I say, let's calculate the initial condition, because this time we are having two energy storing elements in the circuit, and one energy storing element is inductor and another energy storing element is capacitor. So can I say every circuit position, every switch position is a stable position. So we have started our analysis from t equal to minus infinite. So can I say at t equal to 0 minus, we have achieved the steady state for position number P. This point is steady state point for switch position P. So how circuit will behave in steady state? The circuit will behave in steady state. Inductor will be short circuited and capacitor will be open circuited. This is the basic theory we are having. So can I say my circuit will looks like this. If I draw the circuit at T0 plus, if I draw the circuit at T0 minus, we are having 20 volt. Then we are having one capacitor. So I will use this capacitor here. And what is the value of capacitor? The value of capacitor, value of resistor is 20K. Then we are having one 5K resistance. So this is one 5K resistance. Then we are having what? One more 5K resistance. Then we are having one more 5K resistance. Then after this 5K resistance, there is a capacitor, and that capacitor is what? I can call this capacitor as VC 0 minus, because I will copy this potential at VC 0 plus, and I am calling this two values as 5K. This value is also 5K, and one more branch is there. And how this branch is looking like? A 10 kilo ohm resistance here. 10 किलो ओम के रेजिस्टेंस के बाद एक इंडक्टर है जो कि स्टडी स्टेट में कैसे बिहेव करेगा? इंडक्टर स्टडी स्टेट में बिहेव करेगा एज ए शॉर्ट सर्किट. इंडक्टर स्टडी स्टेट में बिहेव करेगा एज ए शॉर्ट सर्किट, एंड आई एम कॉलिंग दिस करंट एज IL0 माइनस, बिकॉज इस बार हमारे पास सर्किट में दो एनर्जी स्टोरिंग एलिमेंट हैं. और अगर दो एनर्जी स्टोरिंग एलिमेंट हैं, अगर आपके पास सर्किट में दो एनर्जी स्टोरिंग एलिमेंट हैं, तो दोनों का आपको इनिशियल कंडीशंस देखना पड़ेगा. चलें देखें. यहां अगर आप देखें तो ये 20 वोल्ट हुआ, 20 वोल्ट हुआ, तो यहां फ्लो होने वाला करंट कितना है? 1 मिली एम्पियर. करेक्ट. और 20 वोल्ट डिवाइडेड बाय 20, यहां जाने वाला करंट भी कितना हुआ? बिकॉज इन पैरेलल वोल्टेज इज सेम. तो अगर इन दोनों पॉइंट्स के बीच का वोल्टेज 20 वोल्ट है, तो इस पूरे सर्किट में यहां का वोल्टेज भी कितना है? 20. एंड 5 kilo ohm and 5 kilo ohm resistances are in series, and this 10 kilo ohm is also in series. So 20 volt divided by 20, this current is what? 1 milliampere. If this current is 1 milliampere, what is potential drop across 10 kilo ohm? Can I say this potential drop is 10 volt? And what is current inside this? The current inside this is 1 milliampere. So can I say हमारे पास जो सर्किट अवेलेबल है उसमें जो स्टोर्ड करंट का वैल्यू बना, दैट वैल्यू इज IL0 माइनस इक्वल टू IL0 प्लस. इंडक्टर के अक्रॉस करंट एब्रप्टली चेंज नहीं होगा, और अगर नहीं चेंज होगा तो व्हाट दिस वैल्यू इज इक्विवेलेंट टू? दिस वैल्यू इज इक्विवेलेंट टू 1 milliampere, while the value of VC0 minus equal to VC0 plus equal to how much? The capacitor will have the value of 10 volt. Correct. दिस इज द कंडीशन ऑफ द टू एनर्जी स्टोरिंग एलिमेंट इन द सर्किट, कि सर्किट में अगर दो एनर्जी स्टोरिंग एलिमेंट है तो दोनों एनर्जी स्टोरिंग एलिमेंट का बिहेवियर कैसा होगा, तो दोनों एनर्जी स्टोरिंग एलिमेंट का ये बिहेवियर होगा, दोनों एनर्जी स्टोरिंग एलिमेंट का बिहेवियर कुछ ऐसा होगा, करेक्ट। इफ नाउ वी आर इंटरेस्टेड इन dV derivative of this voltage, so let's draw this circuit at T0 plus. If I draw this circuit at T0 plus, okay, if I draw this circuit at T0 plus, how this circuit will looks like? We are having initially, now what we can copy from here to here, this point. IL0 minus the current across inductor and voltage across capacitor. This initial condition you can copy from T0 minus to T0 plus. Fine. So let's draw our circuit at T0 plus. How circuit will looks like it looks at T0 plus. At T0 plus the circuit has moved to the position number Q. So can I say at T0 plus the circuit has reached at this position, at position Q, and position Q is what? A short circuited branch. Then we are having what? A 5 kilo ohm resistance. This is 5 kilo ohm resistance. We are drawing our circuit at T0 plus. Then we are having what? One capacitor. And what is capacitor? Capacitor is 1 millifarad capacitor. And what is potential across the capacitor? The potential across the capacitor is given as 10 volt. This value is also given, and this value is 10 volt, initial voltage. What else is given? 10 kilo ohm resistance is given. So this is 10 kilo ohm resistance. And can I say the inductor can be replaced by what? The inductor can be replaced by a source of 1 milliampere in downward direction. So can I say this I can replace by 1 milliampere. Correct. This is our circuit at T0 plus. Or you can say that here we can draw inductor also. Inductor is having value 0.1 millifarad, but we can say that initial condition of the initial current of the inductor is what? Initial current of the inductor is given as 1 milliampere. The initial current across the inductor is 1 milliampere. This current is what? This current is also already known. That current is equivalent to 1 milliampere. Now we can find the value. Can you tell me what is the current which is at T0 plus we are having in this branch? So if I replace this bottom point by reference, अगर इस bottom point को 0 से convert कर दिया जाए तो इस point का voltage हो जाएगा 10 volt. अगर ये 10 volt है तो इस branch में जाने वाले current का value हो जाएगा 2 milliampere, because 10 divided by 2 milliampere is current which is going away from the node. 2 milliampere is the current which is going away from the node. At T0 plus, T0 plus पे 2 milliampere is going away from the node. 1 milliampere is also going away from the node. Can I say this means 3 milliampere is the current which is coming to the node. 3 milliampere is the current which is coming to the node. Can I say what is the current across capacitor? C dVt divided by dt. And this current minus of this is equivalent to what? 3 milliampere. Why I am writing minus? Because the mentioned polarity of the voltage is what? Mentioned voltage polarity is plus minus, but our current will entering into this direction, opposite direction. So this will be minus of this. And this is true only at t equal to 0. So at t equal to 0, dVt divided by dt, this value is given by minus of 3 milliampere divided by the value of capacitor, and value of capacitor is what? 1 millifarad. So if you cancel this value will be -3 of volt per second. तो इस क्वेश्चन के लिए जो करेक्ट आंसर होगा वो कितना होगा कि आपसे अगर बात की जा रही है रेट ऑफ चेंज ऑफ वोल्टेज के बारे में, तो रेट ऑफ चेंज ऑफ वोल्टेज जो इस सर्किट का होगा वो कितना होगा, दैट रेट ऑफ चेंज ऑफ वोल्टेज इज इक्विवेलेंट टू -3 वोल्ट पर सेकेंड. सो कैन आई से द करेक्ट आंसर फॉर द क्वेश्चन इज दिस, -3 volt per second is the correct answer for the given question. A very simple question. So don't try to write the complete solution by taking Laplace or any of the analysis. We can write the solution but not needed for, because they are asking the value at 0 plus, and 0 plus, at 0 plus this whole circuit act as a DC analysis. How you performed your DC analysis. So it's a very simple. I hope this is clear. Let's go to the next question. Next question is GATE 2024 question, and what this question is saying, this question is saying that the ideal switch has been, what is meaning of ideal switch? The meaning of ideal switch is very simple. It is make before break switch. Means it is take zero transition time, है ना, कि एक पॉइंट से डिस्कनेक्ट होने से पहले दूसरे पॉइंट पे कनेक्ट हो जाएगा, ये हमारा अजम्पशन है स्विचिंग का. अदरवाइज उस मोमेंट में जो होने वाली चार्जिंग डिस्चार्जिंग की एक्टिविटी वो भी कैलकुलेट करना पड़ेगी. So we are calculating which switch? Ideal switch. So what they are saying, the ideal switch has been open for a long time. For a long time means for t less than 0. For t less than 0, what is the condition for t less than 0? Switch was open. And what is the switch position for t greater than 0? For t greater than 0, switch is closed. These are two switch positions. These are two switch positions. Now what they are saying? They are saying that the magnitude of current in 4 kilo ohm resistance. Okay, they are talking about this current at T0 plus. What will be the value at T0 plus? Let's analyze this circuit for T0 minus and T0 plus. Can I say if the switch is open at T0 plus, you are having two energy storing element. But we are not afraid of two energy storing element, because this energy storing element will be charged and act as a DC sources, DC voltage and current sources. So can I say every switch position is a steady state position. With the help of this concept, if our circuit has started from t equal to minus of infinity, can I say t equal to 0 minus is steady state point. This is steady state point for switch open, when switch is open. So how you can draw your circuit at t equal to minus, at t equal to 0 minus, I can draw my circuit like this. This value is 10 volt. This value is 10 volt. Here we are having 5 kilo ohm resistance. Then we are having one capacitor. How capacitor will behave in steady state? The capacitor will behave as open circuit in the steady state, and let me call this voltage as Vc of infinite, Vc of 0 minus. Always remember, Vc of infinite is also steady state point, but for open switch, this is steady state point. Switch is open, so we are having 4 kilo ohm resistance here. Here we are having 4 kilo ohm resistance. Then we are having 1 kilo ohm resistance. So here we are having, and switch is open, so there is no meaning of switch. Then we are having 1 kilo ohm resistance here. And can I say my inductor will act as a short circuit. How our inductor will behave? Our inductor will behave as a short circuit. And this current I am saying IL0 minus. Why we are doing this? Because because these are two energy storing elements, and in energy storing elements we can copy from network. Now you can say this is very simple analysis. 10 volt is applied potential, and every element will appear in series. 5 kilo ohm, 4 kilo ohm and 1 kilo ohm. So can I say the total resistance is what? 10 kilo ohm. So 10 volt by 10 kilo ohm, what is the potential drop? So you can say 10 volt by 10 kilo ohm, so current is equivalent to 1 milliampere. How we are writing the current? 10 volt divided by IL0 minus equal to what? 10 volt divided by 10 kilo. And 10 volt divided by 10 kilo is equivalent to what? 1 milliampere. So what is current inside the network? The current inside the network is 1 milliampere. Now we are interested in VC0 minus. So you can say at VC0 minus this potential is 5 volt. So you are applying 10 volt and 5 volt is the drop across resistance. So what is potential here? The potential here is 5 volt, or you can say this potential is what? 5 volt. The circuit is having two energy storing element. This circuit is having two energy storing element, and this two energy storing elements, we know the initial condition. The voltage across capacitor is 5 volt and initial current, initial condition of the inductor is 1 milliampere. So can I say from this analysis we are aware of these two things? VC0 minus equal to how many volt? 5 volt, because 5 volt is the open circuited potential across what? Across this capacitor. And IL0 minus, inductor at 0 minus, is given by how many ampere? This value is 1 milliamp. Correct? Now we can draw our circuit at T0 plus. We can draw our circuit at T0 plus. And how we can draw our circuit at T0 plus? We can draw our circuit at T0 plus by replacing both the energy storing element by these two values. So the circuit just after switching looks like this. Circuit at T equal to 0 plus just after the switching, because they are interested only this value. Which value they are interested in? They are interested in the current at 4 kilo ohm. So let's calculate this. What we are, and at T greater than 0 the switch was closed. So can I say we are having 10 volt here. And now this is one easy question of your KVL KCL, your basic first unit question. Once you able to draw this network, this is your this is your question of first unit. 10 volt, then we are having 5 kilo ohm resistance here. This is the 5 kilo ohm resistance. What else we are having? We are having one capacitor, and capacitor is now replaced by what? A 5 volt source. And this circuit is only valid for T greater than 0. Let me write. Five volt source. What else is given? Here 4 kilo ohm resistance is given. Is this 4 kilo or 5 kilo? 4 kilo. 4 kilo ohm resistance is given. What else is given? The switch is closed now. If switch is closed now, you can say this is short circuited. And this is 1 kilo ohm resistance. And what is value of this? Inductor is having value of what? Inductor current is 1 milliampere. So you can copy this current from 0 minus to 0 plus. You can always copy this current. Current across inductor and voltage across capacitor you can copy. So I will replace it by what? A current source of 1 milliamp. Correct? This is our circuit which is valid at T equal to 0 plus. Our nature of the circuit at T equal to 0 plus is given by this expression. Now, can I say I am interested in this current? How difficult is to calculate this current? Fine. If this voltage is 0, what is potential here? 0. If this potential is 0, this potential is, if I am considering this voltage as my reference voltage, due to short circuit I can copy this 0 volt here. If this 0 volt is here, what is current going from this branch? The current going from this branch is 1 milliampere. Okay. This potential is what? 5 volt. 5 minus 0 divided by 4. What is current coming from here? 1.25 milliampere. Because how to write the current across a resistance? Can I say this value is 5 minus 0 potential difference divided by resistance 4K. So this current is 1.25 milliampere. This current is minus 1.25 milliampere. Now we can calculate every current. They are asking the current at 4 kilo ohm resistance. That value is 1.25 milliampere. 1.25 milliampere. But we can calculate everything across this network. If this current is 1.25 milliampere, this current is 1 milliampere. Can I say the current in this short circuited is what? 0.25 milliampere. And if this current is what? Current going from this branch. What is current in this branch? The current from this branch is 10 minus 5. 1 milliampere. If 1 milliampere is incoming current, 1.25 milliampere is outgoing current. Who is supplying the remaining current? This 5 volt will supply the remaining current. 0.25 milliampere. So we can find the every current in the circuit at T0 plus, and this is the question of DC analysis of a network. There is no transient applied to this network. I hope this is clear. But what they are asking the current across 4 kilo ohm resistance, that is 1.25 milliampere. Fine. Let's try a few more questions from previous year. Okay, this is one previous year question, and what is given for this question? The circuit, the switch S is closed at t equal to 0. So initially switch is open. If initially switch is open, we are having only one energy storing element. If you are having only one energy storing element and switch is open, means no current will flow through this. If no current will flow through this, can I say the initial condition is of inductor is always is given in this question, and they are saying that the value of IL0 minus equal to value of IL0 plus, and this value is what? 0 ampere. This value is 0 ampere. Now what they are asking? They are asking that what is the current in the inductor. Let's talk about that. So can I say our circuit for t greater than 0, how circuit will looks at t greater than 0? At t greater than 0, the switch is closed. So circuit will looks like this. Let me draw it on next page. For t greater than or equal to 0, how our circuit will looks like? Our circuit will looks like this. This value is I of S. This value is I of S. Or let me write it. The current source value is given as I of S. What else is given? One resistance is given, that is R of S. This value is R of S. What else is given? Now switch is closed. This value is R. And this value is what? L. Correct? And what is current here? The current here is given as IT. Fine. This is the total. They are asking by di by dt, means the derivative of this current. Can I say what is potential drop across this component? If IT current is entering from here, can I say the potential drop of this component is L into dit divided by dt. Correct? Now, what is potential drop across this component? The potential drop across this component is IT into R. Two potential will know. In this loop, we are having 3 components and potential across 2 components are known. So can I say what is current in this branch? If this current is IS and this current is IT, what is current in this branch? The current in this branch is given by IS minus of IT. So what is potential drop here? The potential drop here is IS minus IT, IS minus IT into R of S. Yes or no? You can take this or opposite of this, both are fine. How we are writing the potential across RS? The potential across RS is given by this. Let me write it. This is RS. The potential across this is IS minus of IT multiplied by RS. I hope this is clear. Now we can apply one KVL to get answer, because the potential across every component is known. So I can say, if I am writing this is RS. Let's apply the KVL. Let's apply the KVL in the network. Can I say, if I apply the KVL in the loop, if I apply the KVL in one of the loop, can I say you are going negative to positive? This value is RS times of I of S minus IT. Correct? And this is what? This is the potential across. This is the potential across resistance. Then you are going plus to minus. So this value is minus IT into, this value is minus of IT into R. And this value is what? Minus of L DIT divided by DT. This is the kind of differential, and sum of this voltage is equivalent to 0. This kind of differential equation is available to us at t greater than or equal to 0. Now what I can say that I am interested in di by dt at t equal to 0 plus. But what is the value of current at 0 plus? The value of current at 0 plus is 0. So can I convert this equation? Because this differential equation is valid for t greater than or equal to 0. So let me write the equation for t0 plus. So this potential, this thing will be 0, this thing will be 0. So can I say RS into IS, we are writing equation at which point? T equal to 0 plus. So this value will be IS into RS. I0 plus is 0 minus of L into DI0 plus divided by dt. This value equal to 0. So can I say the value of DI0 plus divided by dt, this value is given by RS into IS divided by L. And how much is this? This is this much of ampere per second. So which option is correct for the question? The correct option for the question is RS into IS multiplied by L. This is correct option. Try to answer it with the fundamental. Try to answer it with the fundamental. So it's a very simple question. This is like the when they are asking question on initial condition, you can apply DC, the concept of DC network, and you can approach all the circuits. Let's go to the next question. What is next question? Next question is again one previous year question, 2-mark question, and they are asking this current I1 at 0 plus. What is the current I1 at 0 plus? And switch is going from position 1 to position 2. So let me draw this network. This value is V. Initially switch is connected to, and here they are saying that here we are having one resistance R. Then we are having one capacitor. Then after capacitor we are having one inductor. After inductor we are having one R, and then we are having one C. RC, LC. Okay. And how position is of switch? The position of switch is going like this. Initially it is connected to the position number 1. and position number 1, 2, this is going to the position number 2 at t equal to 0 plus. So they are interested, the question is interested in calculating this current. What will be this current? I1t they are asking. Okay, they are calling this current as I1 of t, and they are calling this current as I2 of t, and they are interested in the current I1 of t. What will be the value of I1t current? Try to solve this question, and then I will, so after 5 minutes I will solve it. What is the behavior of circuit at T0 minus? Try to solve this. And these are 4 options: minus V by 2R, minus V by 4R, minus V by R, and 0. Okay. So let's approach this. How to analyze this? Analyze this circuit at T0 minus, then replicate this voltages at T0 plus, means the voltage of capacitor and current across inductor. So how our circuit will looks like at T0 minus. T0 minus, which is the switch position? Because every circuit is started from t equal to minus infinite. Every circuit is started from t equal to minus infinite. So you can say that t equal to 0 minus is one steady state condition. So let me draw the circuit at position 1 in steady state. Let me draw that circuit. So if I draw the circuit in steady state, how this circuit will looks like? The voltage source V is applied. Here we are having one voltage source V. One voltage source V is given. What else is given? Then there is no meaning of this resistance R. Next, capacitor is open circuited. Then we are having one inductor. Then we are having one resistor R. Then in steady state, the capacitor is also open. Correct? This value is R. This value is L. And how L will behave? The L will behave as a short circuit. How inductor will behave in steady state? So this value is short circuited. So we are having 1, 2, 3 energy storing element. Out of these three energy storing element, 2 elements are open and 1 is short circuited. Now, if we are talking about the voltage across a short circuit terminal, that value voltage is equivalent to what? That voltage is equivalent to 0. So you can say the voltage across this capacitor is what? 0. What is current across the capacitor? The loop is open from here, the loop is open from here. So IL0 minus is also equivalent to 0. Correct? And what is this potential? So if you are applying V potential here, this potential will be what? V volt. So only one capacitor, the capacitor number 1 is charged, remaining inductor and capacitor are uncharged inductor and capacitor. I can copy this voltage. I can copy this voltage from Vc0 minus to Vc at T0 plus. The voltage of the capacitor and the current of inductor I can copy from T0 minus to T0 plus. At T0 plus you can copy this. If you can copy this at T0 plus, can I say, if you can copy this at T0 plus, let's draw the circuit at T0 plus by replacing these values. So now the circuit has arrived at position number 2. So for circuit which is circuit at T0 plus, the circuit at T0 plus, how circuit will looks like at T0 plus? Circuit T0 plus पे कैसा दिखेगा? वो ऐसा दिखेगा कि स्विच का पोजीशन हो चुका है अब R. तो ये मेरे पास है, this is one our reference point. Now we are having new position of the switch, and new position of the switch is what? R. Now we are having one capacitor, और कैपेसिटर जो चार्ज हो चुका है वो किस पोटेंशियल से चार्ज हुआ है? V. The polarity is very important, और इसकी पोलरिटी क्या है? अगर आप देखें इसकी पोलरिटी, तो इसकी पोलरिटी है प्लस माइनस. दिस इज माइनस प्लस, तो और ये पोटेंशियल जीरो है, तो ये कितना होगा? मीन्स इफ यू अप्लाई द KVL, दिस इज V एंड दिस इज माइनस V, और इसके अक्रॉस तो पोटेंशियल जीरो है, तो ये भी कितना होगा? जीरो. KVL is satisfied. So we can say this potential is V. How inductor will behave? तो स्विचिंग से पहले इंडक्टर में अगर 0 एम्पियर करंट था, तो स्विचिंग के बाद भी कितना रहेगा? 0 एम्पियर. एंड इफ करंट इज 0 एम्पियर, कैन आई से द इंडक्टर विल बिहेव एज ए ओपन सर्किटेड वन. नाउ व्हाट इज द वोल्टेज अक्रॉस सेकेंड कैपेसिटर? तो स्विचिंग के पहले जो वोल्टेज था, दैट वोल्टेज वाज 0 वोल्ट. If before switching it is 0 volt, after switching it will act as a short circuit. So you can say here we are having R, और आपके पास जो एक कैपेसिटर है, that capacitor will act as a short circuit. तो T0 प्लस पे अगर हम सर्किट ड्रॉ करेंगे तो सर्किट will looks like this. अब इस कंडीशन में देखें तो कोई दो लूप है ही नहीं. अगर T0 प्लस पे देखें तो there are no two loops, only single loop is available in the circuit. और सिंगल लूप से करंट किस डायरेक्शन में फ्लो होगा? करंट इस डायरेक्शन में फ्लो होगा. अगर मैंने इस करंट को अज्यूम किया I0 प्लस, तो करंट विल बी I0 प्लस इन दिस डायरेक्शन. तो यहां से जो पोटेंशियल बनेगा वो बनेगा प्लस माइनस R इंटू I0 प्लस. करंट ऑलवेज इंटर्स फ्रॉम द पॉजिटिव पोलरिटी. एंड व्हाट इज करंट इनसाइड दिस? द करंट इनसाइड दिस इज R इंटू I0 प्लस. Now we can apply the KVL in the circuit. And what is KVL? KVL is sum of voltages inside the closed loop is equivalent to 0. Sum of voltages inside a closed loop is equivalent to 0. So this value will be what? R into I0 plus. This value will be what? Minus of V. And this value will be what? Plus R into I0 plus. So what is current? Current is V divided by 2R equal to I0 plus. But let's look at the direction of current. In which direction they are asking the current? They are asking current in this direction, clockwise direction, and our current is in anti-clockwise direction. What is direction of our current? Our current is having this direction. Means what is answer for according to their current? So can I say I10 plus equal to I20 plus, because at T0 plus no two loops, only one loop is there, and that current is opposite of our current, and our current is V by 2R, so their current will be minus of V by 2R ampere. Minus V by 2R ampere is correct answer for the question. So you can address all the questions. You can address all the questions with the help of what? You can address all the question with the help of basic DC analysis. So here current is minus V by 2R. Minus V by 2R means first option is correct for this question. Okay. let's take one more question, and this question is also, this question is a question from initial condition, and what they are asking, they are saying that this is one circuit. इस सर्किट में अगर पैरामीटर्स को देखा जाए तो आपको एक 20 ओम रेजिस्टेंस दिया है. लेट्स से दिस इज वन रेजिस्टेंस 20 ohm. Then okay, 120 ohm resistance, is given, and initially हम बात करें t less than 0 की, तो t less than 0 पे स्विच कैसा था, t less than 0 पे स्विच क्लोज था. So again the idea is same, the every position of the circuit is a stable position. So first position of the circuit is varying from, you are reaching from t equal to minus infinity to t equal to 0 minus. So t equal to 0 minus is the steady state point of which position, when switch is closed. So can I say this is the steady state point when switch is closed. This is the steady state point when switch is closed. So can I say I am having one current source of 2.5 ampere. Current source of 2.5 ampere, the switch is closed, and here we can say one inductor. So how inductor will behave in steady state? The inductor will behave in steady state as a short circuit. So here we are having short circuit, and they are asking that resistance 20 kilo ohm resistance is there, and they are asking that what is this Vx, and this Vx is, this value is 20. Okay, of course they are not asking Vx at 0 minus. Vx at 0 minus equal to what? The Vx at 0 minus is 0, because both the points are connected to the same. Both the points are connected to the short circuited. So you can say the voltage across inductor at 0 minus is equivalent to what? 0 volt. But this information is useless. Why this information is useless? Because across inductor you cannot copy the voltage. So can I say if I take this point as 0 volt, what is potential at this point? This potential is also 0 volt. So what is current in this branch? 0 ampere. So can I say the current in this branch is given by what? IL0 minus, and IL0 minus is what? 2.5 ampere. And current across inductor you can copy from IL0 minus to IL0 plus. You can copy the current across inductor from IL0 minus to IL0 plus. If I can copy this current from IL0 minus to IL0 plus, how our circuit will look at T0 plus, because they are asking Vx at T0 plus, and voltage across inductor can abruptly change at T0 plus. So you can say current at T0 plus will looks like this. The circuit at T0 plus, at T equal to 0 plus, what is the idea? At T equal to 0 plus, the switch is open, this switch is open, so only you are having this kind of circuit. And this value is 20. This value is 5 Henry. Correct? And they are asking potential in this direction. This is plus, this is minus Vx. Now, do you know that what is the value? How I can replace this inductor? This inductor at T0 plus can be replaced by a current source of 2.5 ampere. When this 2.5 ampere into 20 volt, 20 ohm, what is the potential? And it is entering from the negative polarity. So you can say minus Vx equal to 2.5 multiplied by 20. And Vx equal to what? Minus of 50 volt is the potential across resistance at 0 plus. At 0 plus, what potential you are having? At 0 plus, this potential is minus of 50 volt. So, which option is correct here? Minus 50 is correct option for given question. Minus 50 is correct option for given question. Let's calculate the next thing. Okay, in this circuit, the energy absorbed by 4 ohm resistance in the interval of 0 to infinite. Okay, can I say the energy across the resistance is given by 0 to infinity Vt into It into dt, and let me write Vt as Vrt and It as Irt. If voltage across inductor, voltage across resistor, the current across resistor, their product is integrated from 0 to infinite, I can calculate the energy. So can I say what is the value of VCT or what is the value of current? So value of current is given by It, and the value of It is I of steady state value plus initial value minus final value into e to the power minus of t by tau for t greater than or equal to 0. Correct? What is the steady state value? In steady state, capacitor will act as an open circuit. If capacitor act as an open circuit, this value, steady state value is 0. Why it is 0? Because in steady state, capacitor is open. What is initial value? Initial value, the initial value of the capacitor is given as 6 volt. So 10 minus 6. Can I say the circuit at T0 plus can be looks like this? A 10 volt. Here we are having 4 kilo. And here we are having 6 volt. So what is current? 10 minus 6 divided by 4. 10 minus 6 divided by 4 is what? 4 or 4? 1 ampere. The current is equivalent to 1 ampere. So you can say the value of It is given by e to the power minus of t by tau for t greater than or equal to 0. This is the value of current. Now we are interested in the voltage across capacitor. The voltage across capacitor is given by the voltage across capacitor. Oh, okay, or we can write the voltage across capacitor, VCT. VCT is also given by Vc of infinity plus initial value minus final value into e to the power minus of t by tau. Fine. What is the voltage across capacitor? The voltage across capacitor in steady state. In steady state, this will be open, so no potential drop. 10 volt is the voltage. Yes or no? Capacitor will act as an open circuit, so 10 volt will appear here. 10 volt. What is initial value? Initial value is 6 volt. 6 minus 10 is minus 4. Here value is minus 4 into e to the power minus of t by tau. Now this value is 10. This value is 10 minus 4. So what is potential drop here? If this value is 10 volt, if this value is 10 minus 4 e to the power minus of t by tau, then what is potential here? From KVL we can write the potential across 4 ohm is 4 into e to the power minus of t by tau. Now we can say the energy is given by energy is given by what? Voltage across inductor and current across inductor. So what is the voltage across inductor? What is the voltage across inductor? The voltage across inductor is 4 into e to the power minus t by t, and current across inductor is given by e to the power minus t by t. You can say energy is given by 0 to infinite 4 into e to the power minus t by t into e to the power minus of t by tau into dt. So you can say this value will be 4 integration of 0 to infinite e to the power minus of 2t by tau into dt. When I integrate this value will be what? 4 into tau divided by 2, and this value will be what? E to the power minus of infinite minus e to the power 0. This value is 4 by 2 tau. Now we are interested in tau. What kind of circuit it is? The circuit is RC circuit, and for RC circuit, what is the time constant? The time constant is given by RC. And what is value of RC? R is 4, C is 2. So tau is equivalent to 8. If tau is equivalent to 8, our energy of the system is 2 into tau joule. So this is 2 into 8 joule, and 2 into 8 joule is equivalent to what? 16 joule. 16 joule is the correct answer for the given question. Correct? Okay. I think this is done for the day. In next class, we will start our analysis on the how to approach the same circuits, the same circuit of first order and second order using the Laplace transform. So our tomorrow's class agenda is to learn to go through the Laplace transform, and for this all same circuits, RL circuit, RC circuit, RLC circuit, we will analyze all kind of circuit. But what is the tool? Because the basic definition of Laplace transform is what? Laplace transform is a tool which converts your differential equation into algebraic equation. So to avoid the discussion of differential equation, we jumped into the Laplace transform. We will jump to the Laplace transform. But you cannot answer in the Laplace transform. You have to again come back to the time domain, and you have to answer in the time domain. It means inverse Laplace is also required. But for very easy circuit, inverse Laplace transform is required. That we will discuss tomorrow. So our tomorrow's class is totally based on the same, the Laplace transform approach for the transient analysis. Thank you very much.